Good morning. My name is Nilesh Raikar and I will be teaching you the course of solid mechanics. So, you have already done your semester 3. Second year is the most crucial year in any engineering curriculum. There you are learning all the core courses. So, this is an core course which is an extension of the course which we have already done, that is strength of materials. So we will today see what is, so today's lecture we will focus on what is the importance of this course, what at the end of semester what you will gain or what you will learn which will be useful in your higher semester. So before we go into the actual subjects, let's start from the root. That is, all of you are engineering students, so what do you mean by engineering? If I want you to define and engineering, what do you mean? What do you learn during engineering? So, to make you think clearly, let's say that engineering versus any other profession. Let's take for example a chartered accountant. So how an engineer is different than chartered accountant, or chartered accountancy. So both are professionals. You are engineering professional, they are finance professionals. So what is the difference? What you learn that is different than CA. For example, a CA could be anybody. What a CA cannot do that you can do, or what you cannot do which a CA can do. So here we will focus what you can do rather than what you cannot do. Anything you have joined and you have done 3 semesters, that is almost 1/3 of engineering. So what does an engineering do? You can design a machine. That's right. Okay, what else you can do? Here we are talking not mechanical engineer, but engineering as such. We'll come to mechanical engineering after that. And after that we'll come to solid mechanics. So first we should know the top level. So engineers can design, that's correct. What else we do? Programming we do. Okay. Nowadays programming is a skill. If you call it as a skill, it is across all disciplines. Here also we need programming. So what you deal with and what the CA deals with. As I said, designing machines, which we are dealing with machines. What else an engineer deals with? If you go to some engineer, like I am an engineer, a senior engineer, so what do you expect me to know? Okay, so you should have knowledge about the technologies. Okay, what else? So we cannot spend more time on this. I thought this will quickly go through. But anyway, if you have never thought what an engineer does, then it is right time now to think what you are supposed to do after you graduate.
You can do research for engineering.
Okay, so research is a general term, but I understand what you mean. You can go into deeper parts of whatever you are written here. But nothing concrete speaks with you, only somebody will come later. Construction, that's an important part. So the main part which engineer does versus CA is what she has just now told, that we build something. So that what differentiates an engineer from others is that engineers are supposed to solve problems and build something. We are not giving sort of advice as to how to save tax or how to increase the profit or how to study the economics so that your business prospers. So that comes in the purview of account professional. Whereas we are into problem solving which are technical in nature other than financial in nature. Both are equally important. But here as an engineer we deal with technical problems and finding practical solutions to them. So not only solutions that it means you have to build some device. So that is, any engineer, computer science engineer, electrical, mechanical, or any branch you take, they will be doing this practical building or construction, what she has said. Okay, now let's come from any other point somebody thinks about engineers, what they do. Okay, so we'll move to mechanical engineering. So let's consider a mechanical engineer versus, for example, again I am taking electrical engineer because the demarcation is easy to understand. So what you as a mechanical engineer do which differentiate you from the students they are sitting in the other classroom. Okay, so you deal with machines. All right, here. Okay, what else? So machine consists of many things. Automobiles, okay, so that is it not a machine? Okay, we deal with different types of machine including automobiles. What you said is correct. Manufacturing, that's very important. As a mechanical engineering, one of the most important knowledge that you must have is manufacturing. In order to qualify as mechanical engineer, you must have sound knowledge of what are the different ways in which you can manufacture something. When you talk about a machine, that machine can be manufactured in different ways. So what are the different ways of manufacturing is an essential skill. So that's why you have learned already. I think you have covered that in last semester. So if you look at subject in third and fourth semester of any engineering branch, they are the essential skills that you should have. So just go through what subjects you have done in previous semester and tell me what skill it corresponds to. Inspection and quality control. Usually it is linked with manufacturing. Yes, that is an quality control, quality assurance. You must have studied them in the same single course, right? Manufacturing. Selection of? Okay, so structures and materials are different things. So we take an automobile or car as an example. So in a car, what is the structure and what is the material? Yes, we illustrate this point. So what kind of material is used in car and why? Is there a single material used in car or there are a variety of materials? Okay, so is there any logic in those variety of materials? Why steel is not used for all components? Okay, there seems to be some logic which you should have understood after your material science course or by common sense.
Depending upon the function that part is to play, according to the result and material.
That's right. So the material is very closely linked to what function or application that particular part is going to do. So material and its selection. A mechanical engineer should have a sound knowledge of materials which are being used in most of the machinery. A civil engineer should have more sound knowledge about materials which are used in buildings, and electrical similarly in the electrical machines. What is structure? So in a car, what is the structure? What knowledge of structure a mechanical engineer should know? Okay, so in case of car, what beam knowledge, what you consider as a beam and what knowledge is required? Is there any beam in the car? No beam. It can be approximated. We are going to see that in many engineering problem solving, we approximate the more complex structures or more complex geometry into a simplified form. So although chassis is a three-dimensional structure with a different shape, in order to approximately understand, we convert into a beam or into a plate. So that is an approximation which allows you to use some standard formulae and solve the problem. So these structures could be, in case of automobile, it could be a chassis or it could be an axle. The various parts. So there are different parts and how to deal with them. So which subject you have come across with deals with designing of different structures? So you said beams. So beams, from where you learned that name? Strength of material. So that's right. So that is subject close to what subject they are going to deal with. So we'll come to that. But there are many other information or many other knowledge that you require as a mechanical engineer. So what are the other core skills of mechanical engineer? Those are the subjects that you are learning. So strength of material we have covered, material science we have covered, manufacturing science we have covered. What other subjects you are learning? Machine design you are going to learn future. So that is an applied course. Kinematics and dynamics. So what they deal with? So structures are dealt by strength of material. The different selection of materials is dealt by material science. Manufacturing techniques dealt by manufacturing science. So COM and DOM you will be learning next semester. So what do they deal with? Which is also a very important part of mechanical engineering knowledge. So they deal with what? Kinematics and dynamics. Which is a very essential skill that a mechanical engineer should have. So if you have to design this bench, then do you require knowledge of COM and DOM? Which object in this room will require knowledge of kinematics of machines or dynamics of machines? Fan. So what is the difference between bench and fan? Moving. So anybody, most of the machines here are some moving parts, some stationary parts. So any moving part is there, you immediately get into the behavior of that part. The behavior of the fan blade is different than behavior of the bench on which you are sitting. So their purpose is that when somebody sits or jumps or dances on the bench, it should not break. Whereas fan, the requirement is different. It is already dancing. So you have to find out how to deal with that. So that is the subject that you will be learning or partly learn. Any other subject that there are some subject that you have skipped? Thermodynamics. So thermodynamics is a very important part of mechanical engineering. So it deals with what? So like we said, motion we have done, structures we have done, materials we have done. So thermodynamics deals with what? What is the heart of thermodynamics? Or the subjects related to thermodynamics?
fluid transfer.
Fluid transfer and heat transfer. So you have to deal with fluid and heat. Usually they come in what type of machines you require fluid and heat transfer or heat as a concept. Or okay, power plant is a much bigger example, but anywhere you require power, whether large amount of power or small amount of power, the heat transfer always comes there in some form or another. So when you are dealing with heat, it is just another form of one of the form of energy. So you require to deal with energy with this subject. Any other subject we have missed? Drawing, that's right. So that is very important. So drawings deal with what? So all these subjects talk about some skill. So drawings is a skill for doing what? Visualizing a product, and that's right. So it is visualization. But you are not using it for your own visualization. You use is an aid for what? For the manufacturer. So essentially it is visualization that you make it easy for a manufacturing person, provided he also knows the language of engineering drawing. So if you give your mechanical engineering machine drawing to a computer science engineer, he will not understand it because he has not learned that language. So it is essentially a language of engineers. So it is language tool, a specialized language which only engineers use. So mechanical engineers have got their own symbols and other things which will be learning, I think it's fifth semester. So that is an important part of your skill set as a mechanical engineer. So what else? So have we covered all your subjects? 5 subjects in last semester, 5 subjects in this semester. Okay. So now we'll come to our subject, solid mechanics. So solid mechanics, as I said, is very similar to the subject which you have learned before. So that is the strength of material. So tell me, out of these skills that we have seen here, so if I ask you question, strength of material, is it related to each of these points? So let's tick them. So is strength of material related to machines? So how it is related? How it will help you to design machines, strength of materials? What way it will help you? So tell me some formula or some concept of strength of material which is useful in machine design or doing some checking for the machine. So you have the ceiling fan, so that is, we have live machine in front of us. So which part of this fan you can analyze using your concept of strength of material? Okay, so there is some electric motor which is supplying torque, and that torque is used to churn the air, that is the fluid around it. So it requires some amount of power, and that is transmitted through the motor shaft to the main hub. So you can use a torsion formula to find out what is the size of the spindle which will transmit the power from electric motor to the main hub. Okay, so that is good. So some concept what you have learned, you can apply it to some real life problem. So automobile, similarly we can discuss about. So machines, automobile, I am just keeping it together. So manufacturing is strength of material knowledge linked with manufacturing in some way. So in a world, everything is interrelated. We cannot separate one thing from another. So here we are talking about strongly related or weakly related. So is strength of material, definitely it is related to manufacturing, but is it strongly related or weakly related? Can you give some example where you can use strength of material to manufacturing?
or any machining process used on a particular material, if that material cannot bear the stress induced upon it by that machining process, then it will break and the heat will not be obtained.
What will not be obtained?
The end product of that.
Okay, yield will not be obtained if the actual cutting, if I understand you correctly, the cutting has to take place.
Before that product gets.
Okay, so where machine strength of material, which concept is useful in machining process? Properties, that's right. So in strength of material you use various material properties. So how hardness is related to machining? So you have done some machining in the workshop. So how hardness is related to machining? Depending on the hardness. So which is easier to machine? Softer material or harder material? Softer material is easier to machine in general. If it is too soft, then also there are some other problems. But this particular linkage between strength of material, what you have learned is through the measurement of hardness. How do you measure the hardness? Which you have learned in strength of material. What is the common unit of hardness? If I tell this material has got 100 units of hardness, so what is the unit of hardness? I think you must have done at least virtual experiment, if not the real experiment. Anybody recollect how hardness is measured?
No, there I used the greener hardness number to calculate.
That's right. So you already know that. So BHN or Greenland hardness number is one of the units for the. So there are other units also like Rockwell hardness and so on. So that is one example of how strength of material gets related to manufacturing. So there are many more, but for the lack of time, we will limit it here. Structures. So what different types of structures at this stage, using the knowledge of strength of material, you are able to analyze? So if I have to design this table, so what parts of this table you can check? If I tell you that you have to design this table so that 100 kg kept at the center, it should be able to withstand. So how many components you can analyze in this table using strength of material? If I put a central load of 100 kg, you know how to design this tabletop? What should be the thickness of this tabletop? How will you do that calculation? Okay, if you keep 100 kg at the center and you have to design what should be the cross section of this leg, how will you check the cross section of this leg? If you are not able to do that, then you have just learned the formulae, but you are not able to apply. I am sure many of you know, but they are maybe reluctant to speak out. So leg is simpler than the tabletop. So how do you design this leg? How much load will come on each of the leg if I keep 100 kg at the top? If I exactly apply 100 or 1000 Newton at the center, how much load will come on each of the leg? 250. It is symmetric if I keep it exactly at the center, otherwise it will change. And how will you check whether it can take 250 Newtons? Compressive strength. So you have the concept of something called as induced stress and something which is permissible stress. So you can calculate what you have learned in strength of material, so how to calculate the induced stresses. So what formula you will use to calculate stress in this leg? So how do you calculate compressive stress in this leg? even if you can skip the answering of these questions now, you are going to face that after your third year when you are giving your campus interviews. So, an interviewer will start with some high level question and he will come down to this question: how do you design a lake of a tech debt? So, as a SPC student, to keep the grace of SPC, you should be able to answer at least that question. You already know that, you said that it is a compressive stress. How do you calculate the compressive stress? Load divided by area. So that is the basic definition. I think you are thinking it is something very complex, so it is as simple as that. So that is the strength of material approach. You calculate induced stress and then you calculate what is permissible, which you get from the knowledge of your materials. So structures is related, so these parts were calculated. Materials is the counterpart of the structure where you know how to calculate the induced stress. You have to check against what is permissible. So there are material properties against which you check. So what is the material property which is generally used for checking purpose? Which you have done experiment in strength of material lab. The very first experiment which you must have done. So what is the output of tensile test? What do you get? That is a property of material which is used popularly for many of the design calculations. So you have given exam just last 15 days back, no? So you have to retain it at least till the time you appear or clear some professional exam. At least you pass your campus interview or you pass your GATE exam or whatever professional thing you are trying. So what is the material property you get through tensile test? Yield stress and ultimate strength or the fracture stress. So those are the two things you require. So that is where material intersects with the strength of material. Kinematics and dynamics. So where does strength of material come in picture? There is no direct linkage with respect to kinematics. So ultimately what you do in dynamics is when a body is in motion, there are inertial forces that get generated. In static like this bench, there is a static load. Whenever there is a dynamic load, it has to be converted into its inertial load. And for that load, you have to calculate using the same approach. So you convert a dynamic problem into an equivalent static problem. Like this fan is whirling. So on the blade of the fan, there is a gravity load which is a static load. And there is what dynamic load acts on this blade. You have this blade which is spinning about the central axis. So what is the dynamic force which will act on this blade? Which you learned in your first year, engineering mechanics. What is that force called? Centripetal and centrifugal force. So how do you calculate the force which is acting on a blade? What information will you require? Velocity and mass, of course, you will require. So m omega square r, that will give you the centrifugal force. So once you know this force, you know that this blade is subjected to a radially acting axial load, and then you can calculate how much stress will be generated. So that is how you will deal with kinematics. Fluids and heat transfer, again it is an indirect combination. So whenever you are dealing with, let's say, an IC engine, an internal combustion engine, so where there are some moving parts. So in order to design those moving parts, you require knowledge about how much thrust is thermodynamically getting generated, how much pressure is getting thermodynamically generated. So you require the knowledge of whatever cycle is undergoing there. And corresponding to that, the engine body should be able to withstand that pressure and temperature conditions. So that is a higher level application of strength of material, and drawings is not per se belonging to any particular subject. It is a language for communicating the engineering concept from one engineer to another engineer, or one technical person to another technical person. Okay, so having seen the strength of material, it is linked here. So what we are dealing now is our subject is solid mechanics. So in solid mechanics is an extension of strength of material. So just like strength of material is linked with all the basic mechanical engineering parts, the solid mechanics is more of a generalized approach. So, for example, if you have to use strength of material to calculate what is the compressive stress in this particular leg, so you have to consider the force divided by area. In most of the cases, you consider this particular part as a part with uniform cross-sectional area, and then you can calculate what is the stress. If it is uniformly tapering, then also you can calculate the stresses. But let's say that this particular leg has got some notch into it, not this vertical slit, but there is some horizontal notch which has come here. So something has hit it and some portion has been removed. So there is a notch into that particular part. So strength of material, the pure strength of material will not give answer as to what will happen around that particular notch. The solid mechanics is a general approach which will allow you to find out what should happen around that notch. So that is one example what I mean by generalized approach. The second aspect of solid mechanics is in order to do generalization, it allows you to make mathematical model of an engineering problem. So this is a very important skill, especially for those who want to do more advanced work in the engineering. So if you are going for thinking of any post-graduation work, or you are thinking of specialized design of some new components or some innovation. So there you cannot use the standard Dawson formula, weighting formula. So you need to devise your own methodology in order to deal with that component. So suppose this particular leg, instead of being a uniform cross section, if it is a twisted bar, so you take a plate and twist it, you will get a spiral plate which is there, and somebody wants to use for some fancy reason that spiral plate as a leg. So what will happen to the stresses in that spiral leg? So if I are having a plate, if I just twist it, you will get a spiral. So that spiral, if you are keeping it here, how to calculate stresses in that is not given in any textbook, or most of the normal textbooks will not give it. The strength of material will give you approach. If the geometry is something like that, how do you write the basic equation which governs that particular geometry and solve it to get a solution? The approach here is more of converting a physical problem into a mathematical model, solve it mathematically, and then relate it back to the real life situation. So we'll see some examples of this particular approach on this particular subject. Don't go by or don't get scared by the mathematics term appearing here. So it is not very high order mathematics that we are talking here. It's routine mathematics. Even if you don't understand the mathematics approach, you can appreciate the beauty that something which is physical can be converted into symbols, and those symbols can be back converted into physical life properties. And as such, this particular subject is more research oriented. So it gives you some skills where you go deeper into a subject. So strength of material, I'm not saying it is not deep, but as you learned it in third semester, it is the surface level knowledge. If you want to go deeper, how those formulae have come, or how those formulae will change if you do some changes. Like I said, if the support leg is a spiral plate, then how do you calculate stresses in that? With this subject, you will get at least some direction to think, or you will know which book to open in order to check that particular thing. So that is the three major differences between the strength of material and the solid mechanics. And in this course, we will be dealing with this more often. So we'll first have quick go through some of the applications of solid mechanics, which are also applications of strength of material, and then we will look into what is the content of this course, and then we'll close today's session. Okay, so we have discussed this particular part in the previous, so I will go ahead. So differences in the focus from strength of material to solid mechanics is solid mechanics looks into more generalization of bodies. So rather than looking at beams and columns, we'll look into an arbitrary shape. So shape could be that of this water bottle. So how do you find out what are stresses in this bottle? So circular bottle, you have learned what is a hoop stress and cylinder. But how do you deal with a general shape? So that would be given by this. And just a corollary of this, in order to deal with the generalization, one needs to know how to convert, for example, this bottle into its mathematical model, solution of which will give us the stresses which are there in the wall of this particular bottle. So if I pressurize this with some pressurized fluid, then this bottle should be able to withstand. So that is very common application in many engineering applications. So that this particular course will give you this skill, and to a very elementary level it will allow you to go into research skills. So here research doesn't mean a technical research, although this course is technical. A basic approach of any research, it may be managerial research, economics research, or a biology research, is always to find or to abstract what is real into some symbolic or abstract model, and then deal with that model with knowledge that you are having. It need not be always mathematical model, but as engineers, we strongly depend on mathematics as our abstraction language, where you convert, for example, your bending stress formula is my by z. So that is a very simple mathematical abstraction of bending stress phenomena. So how do you train yourself to look into problem solving in that particular approach? So whenever you go out to the industry, nobody is going to ask, especially in today's era where AI and machine learning are so much profusely doing. So most likely by the time you graduate, they will not employ you to do bending stress formula. Like my generation, they were depending on humans to do the bending stress calculation, torsion calculations. This calculation most likely by the time you cover 4-5 years of your graduation will be taken over by automation or the artificial intelligence approach, because they are very, very simple and don't require human intervention. What skills they will look for you is the basic knowledge. Some unusual problem comes, then the artificial intelligence depends only on what data exists. So whatever previously has been done, it only depends on that. Luckily, it has got that creativity as of now. But where you differ is creativity, and in order to channelize that creativity, you require the skill where you can convert a physical problem into a model which can be solved. Then you can submit that model to artificial intelligence, and it will give solution quicker than what a human can give. But that step of converting a real life problem or a problem statement into a model is what you will learn in this particular course. Okay, so let's take some example. So what you see here is a plain workshop wise. Where do you use this? You must have used it somewhere in the workshop. So what purpose you are using? Holding the workpiece, maybe for filing or for some operation which you are doing. So if you look at this component, what you see here is the main component, which is the load bearing part in this, is this power screw. So as you tighten this handle and you keep some workpiece here, it will clamp this particular piece. This particular screw, when you are clamping this piece, what is the nature of force which comes on this screw? It will be in tension or in compression? by common sense, what do you think? The screw will get stretched or the screw will get compressed? So if I have to pinch this particular part and if you have some screw here, what do you need to do? You have to pull the screw or you have to push the screw? You have to push, you have to stretch it. So this screw will be coming under tension. So this particular component of this particular machine can be designed using strength of material. So same force divided by area will give you stress and you can design what is the size of this particular screw. But consider the jaws of this particular machine. So this particular jaw is shown here. So if you have to size this particular jaw, so somebody has given some size to this particular component. So if you have to check this particular component, you cannot use your standard knowledge of strength of material because the shape is different than what you have learned earlier. So in order to design this particular part which is shown here, you have to approximate it. If you are using strength of material approach, you have to approximate this as an cantilever beam. So this particular part, you can abstract it as cantilever beam. The remaining material you can consider as an extra material. And then if this particular plate can take the separating force, then this particular jaw is okay. So that is an approximation. But when you are doing business or you are some commercial application of this device, somebody who is producing thousands of these pieces, so that this approximation will give very high thickness of this particular component, which will increase the cost. So somebody would like to optimize. So what is the best shape this particular piece can take? So that can be found out with advanced stress analysis, which generally people do using numerical techniques such as finite element method. So in order, the base of that finite element calculation or stress analysis is the knowledge of what is the stress state, which you are going to learn in the next lecture. And also for vice of this type, another important part is the deformation of the part. So why do you think these components are made so thick? So they are not made so thick just for the purpose of stress point of view. From stress point of view, you could have made them much thinner. The stresses would be still within the yield strength. Why do you think these components are made so bulky? So there is another criteria which always goes hand in hand with stress. So along with stress, you use another term. So what is stress? So strain is related to what? The deformation of the body. So is deformation of the jaw important to you? What happens if the jaw is strong enough to take the stress? Whatever clamping force is there, it can take, but it deforms under that force. What will happen if you start filing with this particular clamp, which is flexible? Will you be able to file it properly? As you apply the filing force, the entire jaw will start shaking. So we require a rigid structure. So the subject of strength of material as well as solid mechanics deal with not only the stress, but the other important part is the deformation, which is normalized by the concept of strain. So after the discussing stress, we will also deal with the strain in this particular subject. So the second example is, this is a part of an nuclear power plant where you have to have the water, that is the steam which is to be generated under high pressure, and it goes into the reactor core. So this particular body contains water at very high pressure, so of the order of hundreds of bar or hundreds of atmospheres. So here the key importance is to that of the safety and reliability. So you cannot, even 1 in million chance you cannot take into failure of this particular component, because that is huge loss not only in terms of capital investment but in terms of the human life and the society surrounding it. If you use the standard strength of material approach, you can design this particular cylinder using your formula of hoop stress, that is PD by 2T, what you have learned there. But note that this particular cylinder has got some attachments, some cutouts, so there you have to pass on the water, take out the steam, so there has to be some cutouts to be made. What you see here is a cutout which is made on this cylinder. So as soon as you make a cutout, there is a local weakening that will happen in this particular cylinder. You cannot calculate the weakening effect using the simple strength of material approach. So you need to have a more advanced tool. So that is the one which is provided by the solid mechanics. Of course, in this course we will not be dealing with this level of complexity, but certainly that is where the application of solid mechanics lies in advanced machine design. So when you are designing some machine components which are highly critical, where you require extreme amount of reliability, you require techniques which are sufficiently accurate. So you can't depend on approximate approach. So you cannot deal with this as a cylinder, and because of hole, you cannot say I will increase factor of safety 2. Instead of considering factor of safety 2, one approach to this in a simple manner is to double the factor of safety. You make factor of safety equal to 4, but the customer, that is a nuclear power corporation, will not allow you to give such vague answer. You have to prove that factor of safety 4 is sufficient for this application. So you have to prove on paper or using the technical skill that factor of safety 4 is okay. For that, again, you will require the knowledge of solid mechanics that we will be learning here. And this is internals of a gas turbine engine. So in this case, you will find there are many rotors and blade assemblies. The aspect here that we are looking here is there are different temperature zones. So as the gas passes, which you are going to learn in maybe future semesters, there are change in temperature and pressure of the fluid as it passes over these blades. Because of the temperature gradient, you will get different levels of thermal stresses that you need to deal with, and that can be analyzed using the techniques that you are going to learn in solid mechanics. So in strength of material, you have seen the example. If you have two rods, they are coupled together. Fixed at both the ends, and you hit them, both of them will get certain amount of stresses. So you know how to calculate stresses in this case, but for this complex geometry, how to calculate those thermal stresses, that needs to be understood by the approach of solid mechanics. Then there are many motion transmission or power transmission elements. Gear is one of the most major one. So what you see here is whenever two gear teeth are getting engaged with one another, so one gear tooth profile will have a specific geometry. Anybody knows what is this profile called? You must have learned in engineering drawing. So there is a specific name to this curve. A cylinder rolling on another cylinder, you get a development curve. So what is that curve? No? You have forgotten or you have not come across this? Wrong is also okay. Rather than nothing, wrong is better. Epicycloid is much complex. This is called as an involute curve. So, epicycloid gears are there, but they are very difficult to manufacture compared to the involute gears. So involute, from manufacturing point of view, involute gears are used. Okay, so cycloid and epicycloid gears, they are very difficult to manufacture. So in old era, they were used to use cycloidal profile, but now they use the involute profile for the ease of manufacturing. Okay, the point here, what we are talking is whenever these curves, the gear tooth, they are touching each other. Theoretically, there is only a line contact. So at this point, there is only a line contact between the two parts. So what you get there, so what is a line contact? That means the contact width is theoretically 0. So if you use your stress formula, force divided by area, since the line doesn't have any area, your stress will become infinite. So these stresses are called as the contact stresses. How to calculate these contact stresses? So using strength of material approach, you cannot calculate them. So in order to calculate them, you have to consider the local deformity that will happen. So whenever high force acts at a particular line, that line no more remains line, but it becomes a surface. So you get that flattened surface momentarily when they are coming in contact with each other, and that gives rise to what is known as contact stress. So in this particular course, we will deal with the contact stress and how to calculate them, which ultimately you will be using in your higher semesters for the mechanical design of gears. And no bodies which are existing in the real life, they are defect free. So there are always some cracks or defects. Even if you see this particular metal frame, which appears to be solid and sound, if you zoom to a particular beyond certain level, you magnify it to a very high extent, you will find that there are many cracks, defects, deformities which are existing there. And how to deal with this real life material which have got some inherent defects into them. So strength of material doesn't consider the presence of these defects. They are dealt with the more advanced studies, what is known as fracture mechanics. So that also in this particular subject we are going to look into. So in short, this particular subject deals with more advanced knowledge about as an extension to strength of material knowledge, which will equip you to deal with more accurately with the problems that you will be facing as an engineer, as a mechanical engineer. When you go to the real life, most of the ordinary problems, they will be taken over either by a software or by some AI agent. They will do the routine calculations for you, and the report will come you only for signature that they are okay. But what the machines, the AI cannot solve or the software cannot solve is the basic fundamental principles based on which those formula or the failure theories are based on. So that knowledge you will get in this particular course. So we'll stop here for today, and if you have any questions, you can ask me now. Okay, before that, we'll look into the course content. Okay, so in this particular course, so these are the course outcomes which you can read from the course content. So whatever I have been telling you, they are written here in the sentence form. So this is what at the end of the course, the skills you will have. The first part is first module dealing with the stress analysis. So we'll be doing the analyzing the stress from up to T1. Most of the stress concepts will be covering. So earlier your definition of stress was force divided by area. We'll bring into what is known as stress tensor. So stress has to be defined in terms of more complex idea. So that we'll understand here. Similarly, the strength as delta L by L, that is the definition that you are having. We'll look into more deeply into the concept of strain in the second module. In the third module, the relationship between stress and strain, you have learned it as a Hooke's law, that is stress by strain equal to Young's modulus. So what is the more general approach for that particular equation we will be doing in the third module. In the fourth module, we will look into some simple mathematical modeling. So if you have a cylinder which is subjected to internal pressure, you have developed the thin cylinder formula in the previous semester. If the cylinder is thick, then the formulation is different. So we develop the mathematical model for this problem and calculate the stresses in this model. The fifth module deals with many non-standard problems like torsion of non-circular cross sections. So like this fan blade, it is revolving, but it is also subjected to some kind of a torsion because of the air drag which is acting on that. How to calculate the stresses because of that. Stress concentration problem, if this fan blade has got some notch or some scratch on its surface, what happens because of that? And contact problem, the gear contact problem what we have talked, thermoelasticity, the thermal stresses, so we will deal here. Then a very powerful approach in any mechanics problem is the energy approach. So many problems can be solved in a relatively convenient way if you use the energy approach, especially if you are dealing with problems which are dealing with impact. So if I shoot a bullet on this particular fan or on this particular table, how deep it will penetrate, whether it will break the table or it will not. So these problems are solved by using what is known as energy approach. So that is what we will look here. And the last module is related to more advanced topics like how do we deal with material plasticity, that is non-linear behavior of the material, that we will be seeing in the last module. In this particular course, the most important takeaway is course project. So, will be given a simple problem. Means on the surface of it, it will appear simple, but if you look deeper into that, you will have more work to do. So, throughout the semester, maybe in the next week or so, I will release this project. So, it has to be done at the group level, and you will have to solve it. Means at the end of this, you will have to present your findings in the form of a report. And those who are more inclined to deeper study, our library has subscribed to very excellent journals. So related to this subject, these two are excellent journals, which are by, anybody knows what is full form of ASME? Is it? American Society for Mechanical Engineers. So that is a very ancient body and has got very huge knowledge base about the mechanical engineering. So these journals will tell you what is the up-to-date information about this particular subject. So we'll stop here for today, and in the next class we will deal with the actual topic, that is the stress analysis will begin with. This week will not have any tutorial, so today afternoon there is no tutorial. In this week there is no tutorial, and Professor Yadav has told me to inform that the some paper answer books are ready, so just discuss with him when we can see the answer. Okay, any other question?